Hi, in this video, we are going to deal with HCF and LCM. We are going to learn how to find HCF and LCM when we have so many variables with different powers. We are going to learn the rule of HCF into LCM along with the product of the numbers. So we will be covering lots of questions in this video. Do watch it till end and do subscribe to the channel for more informative and learning videos. Okay, now the first thing, HCF is a selection of common primes with the lowest power, right? LCM is product of primes with the highest power. Okay, so now we will learn what is HCF and LCM, and we are given two examples. A is x cube y square and B is x square y. Now, as we know that I have already told over here that HCF is the lower power, right? So lower power of x is x square amongst these two. So we will write that x square and y. Y square is the lower power. So we will write that. Now, talking about LCM, it is the highest power. So, in these two cases, x cube is the highest power and y4 is the highest power. So, that easily we have been able to conclude about the HCF and LCM. Now, here is another example for P and Q where P is xy square, Q is x cube y. What I want you to do, find the HCF and LCM depending upon the highest and the lowest power and leave your answer in the comments below. Okay. Meanwhile, let's do another one. We have A as B cube Q4, B as P squared QQ. Now the question says HCF is P to the power M and Q to the power N. LCM is P to the power N R Q to the power S. We are supposed to find an expression which is M plus N product with R plus S. Now, how do we do this? Okay, over here, first of all, let's talk about HCF. So, the HCF of A and B is given to us as P, M, Q, N. Now, based on our understanding that HCF is always the lower powers, right? So, according to that, it should be P squared and Q cube. Now, equating the powers, what do we get? We get that M equals 2 and N equals 3. Okay. Now, let's find out the LCM also. LCM of A and B. It is given to us as PR and QS. And according to our rules, we know that LCM is going to be P cube and Q4. So here we have our R and S, right? So R comes out to be 3 and S comes out to be 4. Now we just need to substitute these values in the given expression. So M plus N times with R plus S. See, I am trying to write each and every step so that you learn how to write and present your answer in your board paper. Okay. So M plus N times R plus S. Now substituting the values, it gives me 2 plus 3 times 3 plus 4. And what do we get? We get 5 times 7. And here we get 35 as a final answer. It's that easy. These kind of questions are hot favorites for MCQs and they may appear for 2 markers also. Okay. Let's do one more question over here. We have the rule over here. HCF times LCM equals product of the numbers. Now, we have got 2 numbers over here already given as an example. A as 12 and B as 15. First, we will prime factorize. What is 12? 12 can be written as 2 square into 3 and 15 can be written as 3 into 5. So, what is going to be the HCF for 12 and 15? HCF is just 3. That is the common with the lower power, right? And what is the LCM of 12 and 15? That is going to be 2 square 4, right? Times 3 times 5. So that is 4 times 3, that is 12 times 5 is 60. Okay. Now let's substitute things in the rule. So we have HCF into LCM. Let me write it down quickly over here. So we have 3 times 60. What does that give us? 180. And on the other hand, we have A into B, which was 12 and 15. Now what is product of 12 and 15? That is also 180. So here we got the rule, right? Now, this was the introduction to this rule and we have got a rule for 3 numbers. Remember, this rule is talking about only two variables, two numbers. Okay. It doesn't apply to more than two numbers. And if you had seen the previous boards paper 2024-25, there was a question with respect to the LCM, HCF and LCM rule for three numbers. The rule says HCF of PQR into LCM of PQR is never equal to the product. Remember, it's never equal to the product. But what is it equal to? It's mentioned over here, and it is given on the last page of the first chapter, real numbers, in the bottom section. See, NCRT is very easy to understand. You need to read each and every page. You need to pay attention. If not read, but pay attention to the key areas of the book. Okay. Now, we have got a question over here, and this is going to be the last question for this video. Let x and y be two distinct prime numbers. P equals x squared y cube and q equals xy4. R is given to us as x5 y squared. Now we are supposed to find the LCM and HCF of PQR and further check if PQR, LCM and HCF equals to PQR or not. Okay. Now, what I'm going to do over here, first let's quickly find out the HCF of PQR. We know it is the product of the lower powers. So what is the lowest power of x? It is just x. And y, the lowest power is square. Now LCM. LCM comes out to be the highest power of x is x5 and for y it is y4. Okay. Now the left hand side talks about HCF into LCM, right? So that is xy square into x5 y4. That comes out to be x to the power 6 and y to the power 6. While on the other hand, we need to do p into q into r. So let's put in the values. That gives me x square y cube, xy4, and the last x5 y square. Now what we need to do, we just need to use our exponents laws over here, add up the powers of x. That comes out 2 plus 1, 3, 3 plus 1, 5, 3 plus 5, 8. And y, 3 plus 4, 7, and 7 plus 2, 9. So we see they are not equal, right? Because this rule is applicable only for two numbers and not three numbers. Okay. So this was about HCF and HCM, introduction to that, and the rules with respect to two numbers. We introduced the three numbers also. Do keep watching this space. Do subscribe for more informative videos and learn maths, practice more and more maths, do the questions, and leave in your comments if you have any doubts. Bye.